Okay, hello and welcome to Alan Zhang's final project for data science project for CSE8. And so my project was on these two data sets. This first data set is um, just the temperature increases of certain countries, a big long list of countries over 57 years, starting from 1961 to 2018. And see, there's like negative temperature increases. This is all in Celsius. And then the next one is CO2 emissions over, I think, also about 58 years, maybe starting 1960, but we start at 1961 because so it overlaps with the other data set. And this one is just also by countries. And so for each year, it just lists each um, how much carbon was emitted each year in metric tons per capita. And so I have these questions right here. Um, First question is kind of like pretty simple. In the United States, what year saw the highest increase in temperature? Was it in Fahrenheit? Next question is probably like, how does the average temperature change vary across countries? Um, and then the last question is there a correlation between temperature change and CO2 emissions? And so basically, I answering these two questions helps me to answer this last question. So I chose to create first two functions that are, I guess, first allows me to find uh, temperature temperature changes and CO2 change to CO2 emission changes for specified years. And so by first getting these, it allows me to build into other functions that lets me find more complex things. So like by being able to find changes in CO2 emissions or temperature increases, I can find the max temperature increase or the average temperature difference, average temperature change, or and then the difference between average temperature changes between countries. And of course, if there is a correlation between CO2 and temperature increase. And so I'm just going to explain one of my functions really quickly. So this is find max temp increase. This is for the temperature data set. And so I'm supposed to find, this helps me find uh, the greatest temperature increase for a specified country. That's why it takes a string for the country parameter and it returns a float. And that float is in Celsius because the data set is in Celsius. And so I first open the temperature file for R, just reading. And then I have this reader variable to read the file. And then you have this data variable to take what I read into make it into a usable list. I have max value here, 0, place a placeholder at 0, which is going to change, but based on whichever numbers the biggest at this temperature uh, column. And so for row in data, this is a for loop that iterates each element, not their index. And so if row 0 is the first column, and if that first column equals the country in my scenario, it's United States. So if I try and find United States, this one, I didn't count the Virgin Islands because I don't know, just make it easier for myself. And so if it has, if the if row 0 is the United States, it will call this function, which I'll explain in a second, which it basically just returns the actual temperature increase. And if it's greater than max, then it will replace max as that number, as a float, and it rounds it to the second decimal place and returns that value. And then it calls find temp year, which is this first function up here. These are helper functions. And it takes country parameter and year parameter, both are strings, and you return a float because that's the it's a number that you're returning, the temperature increase or change. And so it also opens the file. Another reader variable, data variable, makes it a list. And then for row in, once again, it's the actual element, not the index. In data, this list that I created, if the first one is country and the second row matches the year, then it returns this. So if this year and this name matches, then it will return this. And so that is basically it. Thank you, Lee Reporter. Give me 100.